Hello and welcome to Algebra 2 Lesson 37. In this video, we're going to learn about dividing polynomials. So again, for most of you, if you've taken an Algebra 1 course, you already know how to divide polynomials, and this lesson is nothing more than a review for you. If you haven't taken Algebra 1 or if you kind of struggle through Algebra 1, you can pick this topic up from this lesson. I'm going to kind of start at the very beginning. I'm going to go a little quicker than I did in Algebra 1, but still you can pick it up from this lesson. The first thing I want to talk about is the easiest scenario. If we divide a polynomial, which is not a monomial, meaning it's not a single term only, by a monomial, meaning it is a single term only. So that's what we have here in this first example. Let's say I had 2p to the fourth power plus 4p cubed plus 12p squared, and it's divided by 4p. The very first thing you want to do is write this as a fraction. So let's take this as the numerator of the fraction. So 2p to the fourth power plus 4p cubed plus 12p squared. So that's going to be my numerator. That's my dividend. Then I'm going to put this over my denominator or my divisor of 4p. Now we know from our work with fractions that we could split this up and write this as each term of the polynomial in the numerator over that monomial from the denominator. In other words, I can say this is 2p to the fourth power over 4p plus 4p cubed over 4p plus 12p squared over 4p. And you can just think about taking this format, right? There's a common denominator, and going to this format. It's no different than if I had something like 6 over 2 plus, let's say, 4 over 2, right? I could say this is 6 plus 4 over 2. 6 plus 4 is, of course, 10. 10 over 2 is 5, right? So it's the same thing. All right, so let's erase this, and let's focus on this. So what I want to do is attack this problem piece by piece. And what I mean by that is I'm going to start right here all the way on the left, and I'm going to say 2 over 4. Well, I know 4 divided by 2 is 2, so I can cancel this with this. I'll put a 1 here and a 2 here. P to the fourth power over p to the first power. I can cancel one factor of p, so this would cancel, and this will become a 3. Then over here, I go to this part next. I have 4p cubed over 4p. The 4's will cancel. P cubed over p to the first power is p squared. Then I go to this part. I have 12p squared over 4p. 12 divided by 4 is 3. P squared over p is p to the first power. So just look at what is remaining to write our answer. We have 1p cubed, or just p cubed. This is over 2. Then plus, we have p squared. Then plus, next we have 3p. We have 3p. All right, so p cubed over 2 plus p squared plus 3p. So that's your answer. Now, we know with division we can check our answer. Whatever our quotient is, in this case this is the quotient. This is the quotient. We could multiply this by the divisor, and we would get the dividend back. And I'm not going to do that in the interest of time, but you could pause the video, and you could multiply 4p by each term here, and you would come back to 2p to the fourth power plus 4p cubed plus 12p squared. All right, let's take a look at one more like this. So let's say we have 24k to the fifth power plus 24k to the fourth power plus 12k cubed, and this is divided by 4k cubed. Again, the first thing I would do in this scenario is write this as a fraction. So my dividend goes in the numerator, so 24k to the fifth power plus 24k to the fourth power plus 12k cubed. Then this is over 4k cubed. And then I'm going to split this up. So I'm going to say, okay, I have 24k to the fifth power over 4k cubed. Then plus 24k to the fourth power over 4k cubed. Then plus 12k cubed over 4k cubed. All right, so now what I want to do is just go through and simplify. Let me put equals here. 24 divided by 4 is 6. K to the fifth power over k cubed would be k squared. So the first result here would be 6k squared. Then I'm going to put plus. For the next scenario, again, I have 24 over 4. That's 6. I have k to the fourth power over k cubed. So this cancels, and I have k to the first power. So I have plus 6k. Then lastly, I have 12 over 4, which we know is 3. And then k cubed over k cubed is 1. So basically, that's just plus 3 there. So your answer, or your quotient here, is 6k squared plus 6k plus 3. Now, again, this is division. So if you wanted to check it, you could take your quotient right here, multiply it by your divisor, which is 4k cubed, and you will get your dividend back, which is 24k to the fifth power plus 24k to the fourth power plus 12k cubed. Okay, so that's the very easy scenario that we first deal with when we're dividing polynomials. In an Algebra 1 course, you usually have a section that's just devoted to that, learning how to start out with dividing a polynomial by a monomial. Then you kind of move on and you look at two different other sections. The first thing is dividing polynomials with long division. So you divide a polynomial by another polynomial that is not a monomial. And then you also hit another section where you do this and you have missing terms involved. So the process is similar to when we divided whole numbers. So if you were good at long division, you might want to do a few problems just to kind of get your brain reacclimated to that. We're pretty much going to do the same thing here. The first step to this is to write each polynomial in standard form. And if you have a polynomial that's missing any powers for your variable, you want to put 0 as a placeholder. So I would start out with this example here. 45n plus 5n cubed minus 18 plus 38n squared over n plus 6. So for right now, I'm just going to keep it in this format, but I'm going to write everything in standard form. So remember, I want the highest power on n all the way to the left. So that's going to be 5n cubed. So 5n cubed. Then next I'm looking for squared. So plus 38n squared. Then I'm looking for first power. So plus 45n. Then I'm looking for a constant, or you could say n to the power of 0. So minus 18. Okay, so that's in standard form. Now I'm not missing any powers for my variable. I have a third power, second power, first power, and basically power of 0. So I don't need to write 0 as the coefficient for any missing powers. But we'll see an example of that in a little while. So then this is over. We have n plus 6. So that's already in standard form. I have n to the first power plus my constant, which is 6. All right, let me erase this. We don't need that. Now what we want to do is we want to write our problem in long division format. So you'll recall if you had something like, let's say, I'm going to do this on a different page, 651 divided by, let's say, 31, something like that. Well, we could write this as 651 divided by 31 like that, or we could also write this as 651 divided by 31 like that. This is just long division format. The 651 is the dividend. This is the dividend. And the 31 is the divisor. Okay, the divisor. So the divisor goes to the left of our symbol, and the dividend goes underneath. So we're going to do the same thing. And what I'm going to do, let me just kind of scroll down a little bit so we have some room. I'm going to take the dividend here, and let me label that. This is the dividend. And I'm going to put it under the long division symbol. So I have my long division symbol. And I'm going to write my dividend underneath. So 5n cubed plus 38n squared plus 45n minus 18. And then my divisor goes out to the left. So n plus 6. Okay. So the process for long division with whole numbers, as you'll recall, let me kind of go back down to this example. I'm going to erase this real fast. It's going to give us some room. And let me just scooch this to the left. We use this DMSBR to remember this. This is divide, multiply, subtract, bring down, and then repeat or remainder. A lot of teachers will remind you of the family unit and use a little trick to remember this. They'll say dad, mom, sister, brother, and then rover, right? So the family unit. A mom and a dad, a brother and a sister, and then a family dog. So I would start out with this first step of division. I would say, how many times does 31, which is your divisor, go into, and I'd start out with this piece by piece. So I'd say, how many times does it go into 6? Well, it doesn't. So you could put a 0 here, and you could go through kind of the steps there, or you could just make it a little quicker, and you could expand this and say, how many times does 31 go into 65? Well, 31 goes into 65 twice. So I would put a 2 over the 5, right? Because that 5 is in the tens place. That 2 stands for a 20. And then I would multiply, okay, that mom step. So 2 times 31 is 62. Then I would subtract the sister step. 65 minus 62 is 3. Then I would bring down the brother step. So this 1 would come down. Then I would repeat or remainder, which is the rover step. In this case, we're going to repeat the process. So we're coming all the way back up here, and we're going to divide again. So now 31 goes into 31 one time. We're going to multiply. 1 times 31 is 31. We're going to subtract. 31 minus 31 is 0. There's nothing to bring down. We're at the step where we would repeat, which we're not going to do, or we'd have a remainder, and there is no remainder. So we saw that 651 divided by 31 is 21. Okay? So it's basically the same thing when we start doing our division here. The only real difference here is I'm only going to think about leading terms. So when I look at my divisor here, I'm going to start by saying leading term into leading term. So the question would be, how many times does n go into 5n cubed? That's my first step, or my division step. So I would say 5n cubed over n equals what? Well, I know 5's not going anywhere. It's just n cubed over n. So this would cancel with this and be this, right? N cubed over n would be n squared. So you'd have 5 times n squared. Now, a lot of students make this mistake, and they'll just say, okay, well, I'll just put 5n squared here, and we'll just keep going. You don't want to do that. This has place value just like what we just saw. This is the place to put n cubed, right here in this column. This is the place for n squared. This is the place for n. This is the place for your constants. So my answer is 5n squared, so I want to put it here over the 38n squared. Once we've kind of done that first step, the next thing is to multiply. Now, when I multiply by everything. So I multiply this result here by this whole thing here. So 5n squared times n would be 5n cubed. Then 5n squared times 6 would be 30n squared. Now, I want to subtract away, and the main mistake here is that people just put a subtraction symbol out in front, and they start subtracting. So really, I want parentheses around this. And what I can do is I can just change the sign of each term that's being subtracted away and add. So a quick trick to this would just be, okay, I list everything, and then I just change the sign. So this would be negative, and then this would be negative. Now I can just add. So I'll put a little bar here, and I'll add. 5n cubed minus 5n cubed, that's 0. 38n squared minus 30n squared is 8n squared. Now, my next step is to bring down. So the next term is here. I'll bring that down. So plus 45n. And then I just repeat the process. Again, I'm going to go leading term into leading term. So n goes into 8n squared. And again, if you want to write it out on the side, 8n squared over n, to figure that out, that's fine. Most of you at this point can kind of do that in your head. Okay? We know that 8n squared divided by n would simply be 8n. So we would write plus 8n. And look how it lines up with the place value. This is where 45n to the first power is. This is where 8n to the first power is. So again, we're maintaining our place value there. Now, the next thing is, again, to multiply. So 8n times n is 8n squared. And then 8n times 6 is 48n. Now, I can put a minus sign out in front and put my parentheses. Again, the shortcut to this is just to remember, I'm going to change the sign of everything there, and I'm going to add. So 8n squared minus 8n squared would be 0. And then 45n minus 48n would be negative 3n. Again, I want to bring down as my next step. So I'm going to bring down that negative 18. And then once again, for the last time, I'm going to go leading term into leading term. Okay? So n goes into negative 3n how many times? You're asking yourself the question, what is negative 3n divided by n? So n cancels with n, and I'm just going to get negative 3. So now I multiply. So what is negative 3 times n? That's negative 3n. What is negative 3 times 6? That is negative 18. Now you have the same thing here and here. If I subtract the same thing away, I'm going to get 0, right? And you can prove that to yourself again by changing the sign of everything and adding. So this becomes plus and this becomes plus, and we add. Negative 3n plus 3n is 0. Negative 18 plus 18 is 0. So there's no remainder, okay? And sometimes you have a remainder, sometimes you don't, okay? In this case, we don't. So our quotient is 5n squared plus 8n minus 3. So I just want to show you something. Let me erase kind of everything except for the answer. And I'm going to prove to you that this works. Let me kind of scroll up a little bit. Let's just kind of drag this up here. All right, so what I want to do in order to prove this, I want to multiply the divisor by the quotient. That should give me the dividend back if I got the correct answer. This is how you can always guard against mistakes. It's just like if I had 6 divided by 3, and this equals 2, I could say 2 times 3 gives me 6. It's the same thing. I'm saying 5n squared plus 8n minus 3 times the quantity n plus 6 is going to give me 5n cubed plus 38n squared plus 45n minus 18. It's a more complicated example of that, but it's the same concept. All right, so let's go ahead and do this. If we had n plus 6 times 5n squared plus 8n minus 3. Scroll down a little bit. So n times 5n squared is 5n cubed. Then n times 8n would be plus 8n squared. Then n times negative 3 would be minus 3n. Then 6 times 5n squared would be plus 30n squared. Then 6 times 8n would be plus 48n. Then 6 times negative 3 would be minus 18. All right, so if I combine like terms here, I'll have 5n cubed. And then 8n squared plus 30n squared would be plus 38n squared. And then negative 3n plus 48n would be plus 45n. And then minus 18. Now this is exactly what we had as our dividend. 5n cubed plus 38n squared plus 45n minus 18. So you can see that your division here is correct. When I take the dividend and divide by the divisor, I get the quotient. So my quotient, which is here, times my divisor, which is here, gave me back my dividend, which is here. So you're always able to check your division with multiplication. All right, let's take a look at one where you have some missing terms involved. So we have 32x to the 4th power minus 15x minus 50 plus 12x cubed. This is over 4x squared minus 5. So again, I want everything to be in standard form. And anytime I have some missing terms, I want to put 0 as a placeholder. So this is a perfect example of that. So in the numerator, I've got 32x to the 4th power. I've got plus 12x cubed. Now, in order, I have x to the 4th, x cubed. There is no x squared here. So I can't just leave it off. I've got to have it in there to do my division. So what I want to do is I want to put plus 0x squared. It's just a placeholder. Okay, that's all it's doing. Okay, so we need to have that. Then I put minus 15x and then minus 50. So now this is in standard form and we accounted for our missing term. All right, so for the divisor here, we have 4x squared minus 5. Well, I have 4x squared. I'm missing the x to the 1st power. So I'm going to put plus 0x and then minus 5. All right. So let's go ahead and set this up. And we're going to do 32x to the 4th power plus 12x cubed plus 0x squared minus 15x minus 50. We're going to put that under our long division symbol. And then we're going to put our divisor out to the side. So 4x squared plus 0x minus 5. So I'm going to go leading term into leading term. So what is 32x to the fourth power over 4x squared? Well, I know that 32 divided by 4 would give me 8. X to the fourth power over x squared would be x squared. So I would get 8x squared as an answer. Now, where am I going to put it? I'm going to put it over the x to the fourth power. Not going to put it over the x cubed. Going to put it over the x squared. So I'm going to have 8x squared right there. Let me erase all this, and we're going to multiply. Let me kind of scroll down so we have enough room. Remember, I'm going to multiply this by this whole thing. So 8x squared times 4x squared would give me 32x to the fourth power. 8x squared times 0x would be plus 0x cubed. And then 8x squared times negative 5 would be minus 40x squared. Now I'm subtracting this whole thing away. So again, I want to just change the sign of everything. So this would be minus, this would be minus, and this would be plus. So let's put our little bar there. 32x to the fourth power minus 32x to the fourth power is 0. 12x cubed minus 0x cubed is 12x cubed. 0x squared plus 40x squared is 40x squared. And then we want to bring down the next term. So bring down negative 15x. Let's go ahead and go leading term into leading term. So what is 12x cubed over 4x squared? Well, we know that 12 divided by 4 is 3. X cubed over x squared is x to the first power. So this would be 3x to the first power, or just 3x. And again, I want to do my multiplication. So if I do 3x times 4x squared, I'm going to get 12x cubed. If I do 3x times 0x, I'm going to get plus 0x squared. Then 3x times negative 5 is going to give me minus 15x. Okay, so we want to change the sign of everything and then add. So this will be negative, this will be negative, and this will be positive. Put our bar. So 12x cubed minus 12x cubed would give me 0. 40x squared minus 0x squared would be 40x squared. And then negative 15x plus 15x is 0. So I would bring down my next term here of negative 50. And I would go leading term into leading term. So I would have 40x squared over 4x squared. And so what's going to happen is this would cancel with this, and I'll have 10. X squared over x squared is 1. So this would be plus 10. Now I'd multiply. Let me erase all this. 10 multiplied by 4x squared is 40x squared. Then if I had 10 times 0x, remember 0x is just 0. So if I multiply 10 times 0, I get 0. So I could put a 0 here. I could put plus 0 here and plus 0 here. It doesn't matter. You can even put plus 0x and plus 0x. Just as placeholders so things make sense. Then lastly, I could do 10 times negative 5. That's negative 50. And you can see that this is going to result in 0. Right? So if I change the sign of everything, make this negative, and this positive, 40x squared minus 40x squared is 0. 0x minus 0x is 0. Negative 50 plus 50 is 0. So there's no remainder here. We end up with 8x squared plus 3x plus 10. All right, let's just kind of wrap up the lesson now and just look at one with a remainder. So we have m cubed plus 10m squared plus 27m plus 12 over m plus 5. So everything's already in standard form for you, and everything is there, right? We're not missing any terms. So I can go straight into my long division here. I can just say I have m cubed plus 10m squared plus 27m plus 12. Okay, that's my dividend. Putting that under my long division symbol. And then out to the left, I'm going to have my m plus 5, my divisor. So I'm going to go leading term into leading term. So m goes into m cubed how many times? Well, we know m cubed over m would be m squared. So that goes right here. We're going to have m squared. M squared times m is m cubed. m squared times 5 is plus 5m squared. Again, if I'm subtracting this whole thing away, change the sign of everything and then add. M cubed minus m cubed is 0. 10m squared minus 5m squared is going to give me 5m squared. The next thing I want to do is bring down this 27m. So plus 27m. And I just want to go leading term into leading term. So m goes into 5m squared how many times? Well, we know m squared over m is m, so I would basically have that 5 times m. So plus 5m. Then I multiply. 5m times m is 5m squared. 5m times 5 would be plus 25m. Just scroll down a little bit, get some room going. Now, I want to subtract this away. So this becomes minus, this becomes minus. Change the sign of each term, and then you can just add. So 5m squared minus 5m squared is 0. 27m minus 25m is 2m. Bring down your last term there, so plus 12. And we're going to do one final time, leading term into leading term. So m into 2m. You think about 2m divided by m. The m's would cancel. You'd be left with 2. So then 2 times m would be 2m. And then 2 times 5 would be 10. So we subtract this away. So this becomes minus, and this becomes minus. And we can just add. 2m minus 2m is 0. 12 minus 10 is 2. Nothing else to bring down. This is a remainder. Remainder. Okay? We remember those from long division, right? Basic long division. Now, all we need to do with the remainder is write it over the divisor. What that means is, if I write my answer, I have m squared plus 5m plus 2, then plus, here's my remainder, it's 2 over the divisor, which is m plus 5. So this is the remainder, and it's over the divisor. Okay, that's how you want to write this. Let's say you wanted to check the result. What would you do? Well, you could multiply this whole thing here by the divisor, or you could multiply the quotient part by the divisor, and then just add the remainder. So just say, okay, plus 2. And it's the same thing. It's a little faster if you just multiply everything as it's presented here. So let me copy this. So let's say I just multiply this by the divisor, m plus 5. So I could take and distribute this m plus 5 to each term, right? I could write this as m squared times the quantity m plus 5. Then plus 5m times the quantity m plus 5. Then plus 2 times the quantity m plus 5. Then plus 2 over m plus 5 times the quantity m plus 5. Now, the reason I do that is so that when we get down here, this cancels with this, and I'm just adding 2 at the end. So that's why it's the same either way. If I just didn't have this in here, and I did this multiplication, and then I just added 2, I'm getting the same thing. Okay, so that's why I'm saying it's the same either way. All right, so m squared times m is m cubed, plus m squared times 5 is 5m squared, then plus 5m times m is 5m squared, then plus 5m times 5 is 25m, then plus 2 times m is 2m, then plus 2 times 5 is 10, then plus, again, this cancels, I'm just adding 2. So I'm going to end up with m cubed plus 5m squared plus 5m squared is 10m squared, plus 25m plus 2m is 27m, plus 10 plus 2 is 12. So I get m cubed plus 10m squared plus 27m plus 12. That's exactly what we had as our dividend when we begun. M cubed plus 10m squared plus 27m plus 12.